The problem with this project is I can't trust it. There's no feedback on the servos. The servos are weak. The navigation is really poor because, you know, it pans a beam, but it only has like 5 slices of the environment. And then the math is not good. It needs to be updated. So if this thing like runs into a wall, it'll either have a current spike, and then the system will kind of, I don't want to say brown out, but it stops working because it's pulling too much current and it can't supply it, and then it's just stuck there. So then in that case, the web interface would know something's wrong because a scheduled pull stopped coming in. And the other thing I mentioned is will mention is when it flips upside down, it should tell me, because that happened before. There's a demo of this web control. If you can see, I am targeting the this leg here, this servo. I'm going to raise it by 20 degrees. I filled out this form here, hit set, and it takes a little bit in there. Sorry for this noob film physical and screen at the same time, but I wanted to show something end to end. So here's the robot. When you turn it on, there's a setup, LED blinks, and up here on the web interface, hit refresh, the ESP shows up there. And then you can watch the messages. Oh, let me set this up. So there it's pulling. This forces the WebSocket connection. You can see the ESP blinking too. It's blue. Oh man. These servos are bad. You're just like, oh god. But yeah, so if you want to get the voltage, you can, I have this button here. When you click it, it sends a message down to the robot, and then the robot says it right there, or pings it back, 3.74. It's right there. There's like a 1 to 2 second round trip delay. It's not great, but yeah, so that's one of the things. And then there's the physical servo control that I showed in another clip. And then this here is the, this is another interface. If you refresh, oh crap, I wonder if it already crashed. Try it again. So yeah, this one connects as well. And then as it's moving, it plots like a line of its motion, or like where it's been. And then if it hits an obstacle, a red cube comes up. And this is not relevant anymore, but this is the scanning plotted in 3D. The reason it's not really relevant anymore is because there's like 1,500 data points to transmit, and it's too much to send by the WebSocket on the ESP. So, and also here is the 3D import of the model, which I showed in the previous update. But my point is, I'm working on a design to combine all that into a cleaner interface, which ideally all of these joints are imported separately. I'm trying to zoom, but like I can't. I have to modify the 3JS zoom parameters or whatever. But yeah, and also the rotating is weird because I think the axes are messed up. But anyway, yeah, so I'm gonna try and get some. The other thing I thought about today, because I had this thing roaming around and it flipped over. So I'm gonna make something where when it's upside down, it'll send out an alert. There's an IMU sandwich down there in the middle. So, and then the NED down can tell which way is up and down. So I should be able to extract that relatively straightforward. It's been a while since I worked on that bit. But yeah, I mean, I had a real-time plot of it before where I could rotate the robot and see the arrow point down. Although its accuracy is questionable. So recently I tried to rework the code. You can see these are different branches. This is the one I was working on before. I put the old on there to make sure, but now it's Dev 3, which I was just tired of typing Development 3 Origin. So yeah, you can see how the folder structure is different. Everything's like in the same level now, which I'm not sure I'm a fan of, but Arduino's like, you gotta have the same folder name, man. So that entry point is here, and you know, I'm still screwing around. But the thing I changed is, let me see. Wait. See, I confused myself. Okay, yeah, so this is the newer one. I gotta update these branches. Before 3, there you go. Where do I want to start? No, is it variables? Okay, so initially the servos were all laid out like this, which I'm still doing this convention just because of it helps with the mental. Let me see, is there a picture of it? Where would it be? Oh yeah, here. It helps know, like, this is the front of the robot, and so it says like front right outer servo. That's this one too. But what I changed is the let me see, variables. I used a struct, so then I could put more info into them, like min, max, and then you initialize them like this. These are the standing servo positions, and that's in the this kind of formation. So the front left leg is angled towards the front, back left leg is angled towards the back. So yeah, this helps out, so I can put some values in there, and then that changes the code a little bit. The point of the min max is I was able to put a function, or let's see, I was able to create this safe servo right thing where it checks the min max. The min max, I figured that out by manually moving the servos. I made a little interface that talks to the ESP1 socket. So yeah, that's how I know the min max positions, and then if you try to call something that goes beyond that, it won't move the servos beyond there. So that helps, but the overall goal that I wanted to do was to make the I think I just went back, but I don't know, it's up there. Make the motion easier, because you can see here, like, move forward is just a series of steps, and each of these steps is so if we go to front right leg up, it's like a hard-coded which servo starting end position, and then it goes into this move servos thing, I think is in here. Yeah, and this is a looper I wrote a long time ago, which can take in an array of servos, and then it finds like the maximum minimum motion, and then it moves the servos at like the same speed, same rate. That way the legs don't like shoot off and all the servos can move together, and you can move a bunch of them at once. Like some of the commands, they take in like 8 servos at once. Yeah, I just wanted to try and improve this. This is the struct getter. Here's one that has like a lot, 5, but yeah, there's some that are 8. I think they're in the scan helpers. This is the one where it like moves a lot of joints to do the sampling. But yeah, it coordinates all the servo motions. But the thing I was trying to do is not do this. Like I wanted to be able to say, so this is moving 30 degrees. So you just say 30. But then you have to say which direction, because it could either decrement or increment. And then the other thing is the global variables. There's now the current position. So whenever it writes using that move servo thing, it updates the position. Which the purpose of it was so you'd know where the servos are at any given time. Because if it's at like 30 and you suddenly jump from 50 to 80, you will see this like nasty servo jerk. And yeah, so I try to avoid that. So that's why the gates are hard to do, because all of these motions are coordinated. Like this whole process, all of the servos flow. Like if it went from 50 to 80 here and it has to go to 80 to 100 here, then later on it has to go from 100 back to 80, 80 back to 50. So yeah, it's very time consuming, and right now all I can do is move forward and turn left. I was supposed to like do turn right, but it's hard. You can't just like flip it, because the motions are all based on that initial stance. That less than equal thing. Yeah, right here. So, and I tried to like flip that. I wrote a gate that would switch it, so now it's like parallel on this side, angled on that side, but then it still doesn't just work. Like you have to program the other directions. It's just, I don't know. I have to put some more work into that. This thing doesn't move like in an ideal way, you know, like inverse kinematics or something, where you don't have to like manually hard code the motions. And also, while there's an IMU on board, the accuracy and my lack of understanding of how to use it is not helping me. Like, this robot's supposed to be smart and like dynamic and use kinetic, you know, like if it's falling towards a motion, it'll know because the IMU. But yeah, so there's a lot to it. And the IMU I put work in a long time ago, like months. There's still stuff I have to do, like the magnetometer offset, the accelerometer offset. So that's something I have to do, is like one accelerometer mag only connected to like an ESP. Get that down so then I can integrate it in here. Let's see, where is it? Telemetry. Wait a minute. I'll have to pull the code down, but I made some new interfaces, like to manually command the individual servos. I mentioned that already, and also to get the battery on demand. Which it doesn't work that good because while if it's doing like pan tilt, let me go to it, main. Yeah, so when this part is running, this part doesn't run at all, and this thing here, web messaging, where did I put that? I think in comms. There's like a loop thing going on, because the other part of it, the ESP, it has this looper deal that's waiting for messages from the socket, the website. So I have to figure out how to make this uninterrupted while this can run. I don't know if I have to like stick this in here. Yeah, I'm working on some kind of an interface, and I gotta chunk this down so it's interesting.